Welcome to the AI Checkpoints. Before we dive in, just a quick but important note. This content you're about to hear, much like the advancements we're discussing today, is actually generated by AI. Okay, let's unpack this. We're in an age where AI agents they're getting really sophisticated fast, and that brings up a huge question. How do we make them truly effective, at solving real-world tasks? And here's where it gets, I think, really compelling. What if the AI itself could actually help us optimize the very tools we give it?
Exactly. That's the core of what we're looking at today. We're doing a deep dive into insights from an Anthropic publication, came out September 11, 2025. It's titled Writing Effective Tools for AI Agents Using AI Agents. And it really explores how their Model Context Protocol, they call it MCP, basically lets LLMs use external tools smoothly. And crucially, it outlines techniques to, well, maximize how well these agents perform with those tools.
Right. So our mission today, for you listening, is really to distill those core strategies Anthropic talks about. How do you build good AI tools? How do you even evaluate them? And this idea of collaborating with agents like Claude Code to supercharge the whole thing. The goal is you'll walk away with some clear principles for designing tools that aren't just functional, but actually intuitive for the AI, bridging that gap. Okay, so let's start right at the beginning. What is a tool exactly when we're talking about an AI agent? How's it different from, regular software?
Yeah, that's a really fundamental distinction, and Anthropic highlights it well. See, traditionally when we write software, we're basically setting up a contract between predictable systems, deterministic systems.
Deterministic, meaning like input A always gives output B.
Exactly. You call a function, say get weather, NYC. You expect the same kind of output every time. It's reliable, predictable. But for AI agents, tools are a whole new ballgame. It's a contract between those deterministic systems and, crucially, non-deterministic agents.
Non-deterministic. So, it doesn't just follow a script. It can improvise.
Precisely. It's not always a straight line from input to output.
Yeah.
So if you ask an agent, should I bring an umbrella today?
Okay.
It might call a weather tool. Sure, that's one path. But it could also maybe use its general knowledge, about the local weather patterns. Or it might even ask a clarifying question like, where are you heading specifically to figure out the best strategy?
Ah, so it has options, different paths it can take.
That's it.
Yeah.
And this really forces us to rethink software development, these tools. They have to be designed for agents, not just for us human developers or for other predictable systems. It's a different mindset.
So it's not just bolting on more functions. It's about crafting them in a way that fits how an agent actually thinks or, processes information. What's the ultimate goal here? What are we aiming for?
Well, the main goal, according to Anthropic, is to really increase the surface area where agents can be effective. Give them more ways to succeed, let them pursue different successful strategies. And here's a really fascinating twist they found. The tools that agents find most ergonomic, easiest and most intuitive to use, often turn out to be surprisingly intuitive for humans too.
Huh. That's interesting. So good design for AI might just be good design, period.
It often seems that way. It's like designing for the agent forces a clarity and efficiency that benefits everyone, a kind of universal design principle emerging.
Okay, that synergy idea is compelling. Now, this sounds less like a one-off build and more like constant tweaking and an evolution.
Oh, definitely. Anthropic describes it as a highly iterative approach. It's a cycle.
A cycle.
Yeah, you start with prototypes, then you move into really comprehensive valuations, and often you're collaborating with the agents themselves. It's a continuous feedback loop. Build, test, learn, refine.
So when you're building that first prototype, how do you start?
They stress getting your hands dirty. Try using the tool yourself. It helps you anticipate how an agent might approach it, where the friction points might be, what feels natural, kind of putting yourself in the agent's shoes.
Thinking like the agent. And what do you give the agent so it understands these new tools? Do you just hand it the code?
Not quite. They recommend giving the agent LLM-friendly documentation, like simple text files, maybe lms.txt files describing any libraries or APIs you're using. Then for testing, you can connect your local setup, maybe using their MCP server or these desktop extensions, DXTs they call them, directly to Claude Code or the Claude desktop app.
Okay, so you can test it live, basically.
Exactly. See how it actually works in practice. And just like any software, testing it yourself and getting feedback from early users is huge for building intuition about how it'll be used in the real world.
Right, prototyping, testing, getting feedback. But then how do you know systematically if it's working well, if the agent is using the tools effectively? That sounds like where evaluation comes in.
Precisely. You absolutely need to measure it. Anthropic is clear on this. And it starts with generating good evaluation tasks.
Not just simple tests.
No, definitely not just simplistic sandbox stuff. They need to be numerous, based on realistic situations, using realistic data. And crucially, the good tasks often require multiple tool calls to solve.
Can you give an example?
Sure. A strong task might be something like schedule a meeting with Jane next week, attach the notes from our last chat, and book the main conference room. That's much richer than just schedule a meeting with Jane at acme.corp next week. You see the difference.
Yeah, much more complex, more real-world steps involved. Okay, so you have these complex tasks. How do you check if the agent actually succeeded?
Well, each prompt needs a verifiable outcome. And interestingly, Claude itself can often judge the success. But, and this is important, they warn against being too strict with your verification.
Too strict.
Yeah, you don't want to penalize an agent that achieves the goal, but maybe took a slightly different, yet still valid, path to get there. You want to reward success, not just one specific method.
Okay, that makes sense. Flexibility. And how do you run these evaluations efficiently? You mentioned loops.
Right, they talk about using simple agentic while loops.
Agentic while loops. What does the agentic part mean?
It's essentially a loop where you feed the task to the agent, and then the agent can autonomously make multiple tool calls, gather info, take actions, until it completes the task.
So it mimics that back and forth interaction.
Exactly. You give the agent the task and the tools it needs. And a neat trick they use is instructing the agent, right, in its system prompt, to output its reasoning before it acts, like a little thinking out loud block.
Ah, like chain of thought reasoning.
Precisely. It triggers that kind of behavior, which can actually boost the LLM's effective intelligence. Claude's built-in interleaved thinking does something similar.
And you're tracking more than just success failure, I assume.
Oh, absolutely. You need metrics like runtime, how many tool calls it made, token consumption, that's a big one, and of course any errors it encountered.
Yeah.
All that data helps you pinpoint where the problems are.
This whole systematic evaluation sounds powerful, but the really wild part, the bit that sounds like science fiction almost, is that the agents can help improve their own tools. Is that right?
Yes, this is where it gets, frankly, mind-blowing. Agents analyzing the results and suggesting improvements to the tools they just used.
How does that work in practice?
Anthropic found you can literally just paste the evaluation transcripts, the agent's reasoning, its tool calls, the outcomes, right into Claude code. And Claude is apparently quite good at spotting patterns, suggesting refactoring, improving consistency, and making the tools better.
Wow.
And it's not just theoretical. Anthropic used this very method to optimize their own internal tools. They even found it led to performance improvements beyond what expert humans had initially designed, partly because they used separate test sets to avoid just overfitting to the training data. It's real AI-assisted development.
That is genuinely incredible. AI helping build better tools for itself. Okay, so after all this work, the prototyping, the evaluation, the agent collaboration, what are the big takeaways? What are the core principles for designing tools that really make agents effective?
Well, several key principles emerge from their optimization work. The first one is really about making smart choices up front, about which tools to build.
It's not just more tools equals better.
Definitely not. Agents have constraints.
Right.
Especially their limited context window, that token limit we talked about.
Yeah.
It's not like a computer with tons of memory.
Their working memory is precious.
Exactly. So the example they give is really illustrative.
Mm-hmm.
An address book, a tool like list contacts, it just dumps all your contacts. That's terrible for an agent. It wastes that precious context space.
Right, it has to sift through everything.
Yeah. But a search contacts tool, or maybe a message contact tool, much more targeted, much more efficient, and frankly, more natural for humans too.
So quality over quantity.
Absolutely. Build a few really thoughtful tools for key workflows first, then scale up. And tools can often consolidate multiple steps. Think schedule event. Instead of separate calls to list users, list calendars, create the event.
Streamlining the process.
Precisely. Each tool should have a clear, distinct purpose. This helps agents break down tasks, kind of like how we do, and cuts down on the amount of intermediate information they need to juggle.
Okay, so choose wisely, consolidate functionality. Once you have these tools, how do you keep them organized, especially if an agent has access to many?
That brings us to the next principle, namespacing.
Namespacing, like organizing files and folders.
Sort of, yeah.
Right.
It means grouping related tools using common prefixes, like Asana search, Jira search, or maybe even more specific, Asana project search, Asana search.
And why is that so important?
It helps the agent understand the boundaries between different sets of functions. But critically, it reduces the number of tool descriptions the agent has to load into its limited context. It also offloads some computation and, importantly, reduces the risk of the agent getting confused and using the wrong tool,
Hmm.
especially if they have similar names. It just creates clarity.
Like a well-organized cool box versus a messy drawer. Okay, makes sense. What about the information the tools send back to the agent?
That's another key area. Tools should return high-signal information, contextually relevant stuff, not just raw technical data.
Meaning?
Avoid things like cryptic UUIDs or, 256-piece image role. Instead, use plain language fields. Name, image role, file type, things the agent can directly understand and act upon.
So make it human-readable, essentially.
Exactly, and they found something really fascinating here.
Yeah.
Just resolving those weird alphanumeric IDs into something more meaningful. Even just simple numbered IDs like 0, 1, 2 significantly improved Claude's precision. It reduced hallucinations.
Wow. So the clarity of the data returned directly impacts the AI's reliability.
It seems so. Clearer language, clearer understanding, and they even found ways for the agent to control how much info it gets back.
Oh, right, for token efficiency.
Exactly.
Right.
They introduced this idea of a response format setting like detailed or concise. The agent can choose concise to get just the essentials, saving tokens. They mentioned a Slack tool where concise used only about a third of the tokens compared to detailed. That's a huge saving.
That gives the agent control over its own resource management. Smart.
Yeah, and they also noted that even the format, like XML versus JSON versus Markdown, can matter depending on what the LLM was trained on. Lots of subtle factors.
So optimizing the response is critical for token efficiency. What else helps manage that limited context?
Well, standard techniques like pagination, letting the agent request data in chunks, filtering, range selection, truncation Claude code, for instance, apparently defaults to cutting off tool responses at 25,000 tokens.
Okay, practical limit.
Right. And you also need to guide the agent towards efficient strategies. You can do that in the instructions. Nudge it to do, say, several small targeted searches instead of one giant context-hogging search.
And what about when things go wrong? Errors.
Ah, yes. Don't just return an opaque error code. Prompt engineer the error messages.
Make the error message helpful.
Exactly. Make it provide clear, actionable advice. Instead of error 400, maybe something like parameter start date is missing or invalid. Please provide it in YYYYMMDD format. Turn errors into learning opportunities for the agent.
That's a great point. Even errors become part of the refinement loop.
Okay, so we've covered choosing tools, name spacing, response content, efficiency. What did Anthropic find was like the most effective way to steer the agent's behavior with these tools?
Right, this is maybe one of the biggest levers they identified. Prompt engineering the tool descriptions.
The descriptions themselves. How so?
Well, think about it. Those descriptions, the specifications for each tool, they get loaded directly into the agent's context window. Ah, okay. It's literally part of the agent's instructions for that task.
Precisely. It's their manual. So the advice is treat it like you're onboarding a new team member.
Meaning be super clear.
Super clear. Make implicit things explicit. Avoid ambiguity at all costs. Use strict data models. Name parameters unambiguously, like we said, user RID instead of just user.
Small changes, big impact.
Potentially huge impacts. They mentioned getting Claude Sonnet 3.5 to state-of-the-art performance just through careful refinements of tool descriptions.
Yeah.
It drastically cut down on errors.
That really underscores how much the language we use matters when interacting with these agents.
It really does. It's all about clear communication.
Yeah.
So if we kind of zoom out and connect all these pieces, this deep dive really shows that building effective tools for AI agents isn't just coding as usual. It demands a real shift in how we think about software development. We're moving away from designing for purely predictable, deterministic systems.
And moving towards designing for, well, non-deterministic intelligence. Embracing that variability.
Exactly. It's a fundamental reorientation.
And it feels like it's not a destination, right? It's an ongoing process. This systematic, evaluation-driven approach Anthropic lays out seems crucial for keeping pace. As the agents get smarter, the tools need to evolve right alongside them. It's a feedback loop.
That's perfectly put. It really highlights this continuous dance, this interplay between the growing power of the underlying language models and the cleverness, the ingenuity of the tools we design for them.
So, thinking about our listener,
Huh.
what does all this mean for you? As these AI agents get woven more into our work, our lives, understanding these principles feels important. It's not just for the hardcore developers, right? It's for anyone who wants to really leverage what these agents can do.
I agree. Whether you're building these tools, managing systems that use them, or even just interacting with an agent day to day, knowing how they work best helps you use them more effectively. And it brings up, I think, a really interesting question for all of us to chew on.
Yeah.
What does it actually mean for how we learn, how we build things, when the tools we create for AI end up being designed in a way that's intuitive for both the machine and for us humans? It feels like it's bridging a gap, maybe, in a really profound new way. What does that interaction look like going forward?
That's definitely a thought to mull over. What happens when designing for AI makes things better for humans, too? Well, thank you for joining us on this exploration into the fascinating world of AI tools and agents. Hit like and subscribe if you like the content. We'll see you next time.